Okay, so we're going to look at a couple more examples from solving by using the quadratic formula. Let's move myself here. And open this up. So here's one that's decimals. Again, we can see it's a non-perfect square because there's a y squared term and a single y term. So we need to put it in standard form, which it already equals 0, but I want to get rid of these decimals. So I can treat it similar to how I would to a fraction and multiply everything by some power of 10. So in this case, multiply everything by 100. Both sides of this equation. And when I multiply the left side of the equation by 100, all three of the decimals are going to go away. We're going to get y squared plus 4y minus 3 equals 0. 100 times 0 is still 0. I would think about factoring this, except, factors of 3 that add to 4, well, 1 and 3 do, except I notice their signs have to be different. So you're never going to get a negative 1 and a positive 3 to add to positive 4. So this does not factor. So I'm going to use the quadratic formula, identifying a as the coefficient of y squared is 1, b, the coefficient of the y term is 4, and c, the constant is negative 3. And then the quadratic formula tells me that y will equal negative b plus or minus the square root of, always good to rewrite the formula, b squared minus 4ac all over 2a. It's also good to explicitly identify the a, b, and c like I just did. The advantage there is that now when I go to plug these numbers into the formula, I can do the computations that I know. So for example, negative b, negative 4, would be negative 4. I don't have to do anything there. I can just do that computation. Also, b squared, that's 4 squared, that's 16. So I'll just put a 16 here. And then minus, it's 4 times 1 is 4, times negative 3 is negative 12. So I'm minusing negative 12. So that's going to become a plus 12. Plus, and notice, I could write minus 4 times 3 times 1, but it's just so much easier to write plus 12 here. And I have the formula above, so I can see where it's coming from. And then downstairs, I'm not going to write 2 times 1. I'm just going to multiply 2 times 1, which is 2. Okay, so we've actually have the solutions, but now we need to simplify this. So I'm going to go across, just so that I don't have to, I can maybe fit this all on one page. I'll get negative 4 plus or minus the square root of 28 divided by 2. And I need to reduce this guy down, but I need to be careful. I can't just cancel this 2 into this 4 yet. I first need to reduce this root, recognizing that 28 is 4 times 7. And then come back over here. Negative 4, reducing that root, I'm going to get square root of 4 is 2 times the square root of 7 divided by 2. And so when I do this cancellation, both terms on top have to be, all three terms, the 2 on top and the 1 on bottom, all have to be divided by 2. So all have to be divided by the same thing. So here they're all divisible by 2, so I cancel that out, it goes in 2. So that goes in once, cancel that out, it goes in once. And I get 2 solutions. Notice they're not complex, so XYZ will want you to enter these separately. Negative 2 plus 1, or just this plus 1 times the square root of 7, or just plus the square root of 7, and negative 2 minus the square root of 7. If you need to pause here to copy this guy down, that would be great. Otherwise, I'm going to go on to the next example. And I just want to reiterate what was different about this example before I move on, was that initial step, multiplying everything through by 100 to get rid of those decimals. Okay, next example. Negative 3x plus 2 equals negative 2x squared. So again, I have a non-perfect square because I have, it's quadratic because I have an x squared, and then I have a negative 3x term here, making this a non-perfect square. I need to put this in standard form, which means setting it equal to 0. I want to move the 2x squared to the left side of the equation so that it becomes a positive 2x squared. I always want to keep my a coefficient, the coefficient of x squared, positive. 2x squared minus 3x plus 2 equals 0. Again, I could consider factoring this, but I notice I would have to use an AC method. So a is 2, c is 2. A times c would be 4, and I would need to look at the factors of 4 that add up to negative 3. And you could get 1 and 4, but they would have to be different in sign. And this plus here is telling me that they would have to both be the same sign. So you're never going to get two things that are the same sign that multiply to 4 and add to negative 3. So this does not factor. So again, I'm going to rewrite my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. It's good to say that when you write it down. It helps us remember it. And I write it down every time. And the reason I write it down every time is now, if I have written these down and I wrote the formula down, I can do whatever computations I know how to do. So for example, before I even start writing, negative b will be negative negative 3, which will be positive 3. So I figure that out before I write it down. So I get a 3 here. And then I get plus or minus the square root of, and now I say, well, b squared, that's negative 3 squared. Negative 3 times negative 3 is positive 9. Most likely, if you write inside there negative 3 and you square it, chances are you have an opportunity to put negative 9 instead of positive 9. So it's actually easier to do the computation here as you plug that number in. Minus, and now I'm subtracting 4 times a times c. So 4 times 2 is 8, times 2 is 16. So 9 minus 16 there. And then the denominator is 2a, so 2 times 2 is 4. And again, so I can fit on the page, I'm going to come across. I don't usually do that, but I want to try to make this guy fit here. So 3 plus or minus the square root of negative 7 divided by 4. So I can reduce that square root by taking the I out. So that's going to be 3 plus or minus I times the square root of 7 all over 4. I'm not 100% sure how this looks in XYZ, but it very well could look like this. A box plus or minus a box followed by an I followed by another box divided by a box. So when you have this scenario, they're doing this to try to make it easier for you. I think it actually makes it harder, but I don't have control over this. So how would you enter this in? It'd be a 3 here. There's no coefficient in front of the I, so it would just be a 1. Plus or minus 1i, this would be square root of 7 all over 4. So the data entry can be a little bit tricky here. One suggestion I might have is just use the preview button. Okay, so I think I'll do one more example. If you want to pause this, go ahead. And I will do one more. This example will involve factoring and using the quadratic formula. So how does it involve factoring? Well, this is a sum of 2 cubes. So I can factor that. And how does it factor? Well, it's y cubed plus 5 cubed. So I can factor this. I can recognize this as y cubed plus 5 cubed. So that factors as 2 terms times 3 terms, and it still needs to equal 0. The first 2 terms are y plus 5. As I go in to do these 3 terms, I multiply the first thing by itself. Y times y is y squared. Multiply the last thing by itself. 5 times 5, that's 25. I look at the signs. So this is the same. Leave it. This should be the opposite of that, negative. This should be always positive. So same, opposite, always positive. And the middle term, I multiply these 2 things together. So y times 5, or 5y. So when does this product equal 0? Well, either when y plus 5 equals 0, or when y squared minus 5y plus 25 equals 0. So this guy has a solution y equals -5. This is a real number solution. And the other portion, the quadratic equation that I have there, will have imaginary solutions. So that part of the problem involves factoring. The second part of the problem involves solving this quadratic equation, y squared minus 5y plus 25 equals 0. So here, this is not factorable. I need to figure out what my a, b, and c are. I'm going to scroll down so I can just focus on this part. So a is 1, b is a -5, and c is a positive 25. I'm going to rewrite the quadratic formula. Y equals -b plus or minus the square root of b squared minus 4ac all over 2a. And having written the numbers down, it's then okay to just plug them into the formula. So -5, I figure out before I write down, will be a positive 5, plus or minus the square root of, here's where the real benefit is, -5 squared is positive 25. And then minus 4 times 1 is 4, times 25 is 100. So minus 100 all over 2. And this guy is 5, plus or minus the square root of -75 over 2. So then this is 5 plus or minus, so root 75, that's -1 times 25 times 3. So it's going to be it's going to be 5 for the 25 and I for the negative, left over with a square root of 3. And that's our answer. In XYZ, we'll have 2 sets of answers. We don't want to forget we had a real answer, y equals -5. And then we'll have y equals going to have a box, plus or minus a box, times an I, times a box, all over another box. And I can let you fill those in, or I can just fill them in. That's 5, a 5, square root of 3, and a 2. And these are the imaginary solutions. This one over here, again, is the real solution. So that'll do it for using the quadratic formula. I'm going to go back and do one more video where I derive where the quadratic formula comes from. And again, if you need to pause this guy here, that kind of shows the bottom half of the problem. You can make it so show the whole thing if I just maybe zoom out a little bit. Nope. So I'll just maybe recap it. Top half of the problem, factor it, set both factors equal to 0. That gives us a real solution. On the linear factor, on the quadratic factor, when we set it equal to 0, we use the quadratic formula, and then we get our two solutions, y equals -5, the real solution, and then 5 plus or minus 5i root 3 all over the square root, all over 2. Okay.